Hello students, today we are going to start a new chapter, that is belt drive. In this chapter we are discussing about what is belt drive, what are the purpose of belt drive, what type of material are used to make the belt, and what are the types of belt drive and derivation of open belt drive. Belt, belt drives. The belt drives are uh, are used to transmit power from one shaft to another by means of pulleys which rotate at the same speed or the different speeds. Basic purpose of the belt is to transmit power. There are some factors which are used depends upon the power transmission in the belt drive. The first point is the velocity of the belt. Second one is the tension under which the belt is placed under the pulleys. And third one is the arc of contact between the belt and the smaller pulleys. And next one is there is some conditions under which the belt is used. The shaft should be properly in line to issue uniform tension across the belts. Basically, these are the factors which affect the transmission of power. According to the belt use of belt drive, there are different three types on the use of their uh, working capacity. There are three types. First one is light drives. They are used to transmit small power at belt speed up to 10 meter per second. And basically these machines, these belt drives are used in agriculture machines and small machine tools. Second one is medium drives. These are used to transmit medium power at belt speed over 10 meter per second up to 22 meter per second. This is basically used in small lathe machines, DC motors, where the machine is not that small, but it is used small operation area. And third one is heavy drives. Heavy drives basically these are used to transmit large power at belt drives at above 20. Next one is types of belt. There are three types. For one is flat belt, second one is V belt, and third one is circular belt or rope. First one is flat belt. Basically these belts are used in factories, workshop, where moderate amount of power is to be transmitted from one pulley to another pulley, and the length of that belts are not more than 8 meter. Next one is V belts. These belts are basically used in factories and workshops where moderate amount of power is to be transmitted. And these two pulleys in where the V belt is used, the distance of two pulleys is very closer. That means these are very nearer to each other. Next one is circular belt or rope belt. These are basically mostly used in factories where much amount of power is transmitted from one pulley to another, and when the two pulleys are more than 8 meter apart. These are the circular belts, flat belts, V belts, and third one is the circular belt. Next slide is material used for making the belts. There are basically used materials are leather belts, cotton or fabric belts, rubber belts, and balta belts. Both rubber belt and balta belts are similar materials. In balta belts, instead of rubber, some Balta gums are used to making the belts. Next one is types of flat belt drives. I put some belt drives. That one, first one is open belt drive. Second one is cross or twist belt drive. Third one is quarter turn belt drive. Fourth one is belt drive with idler pulleys. That may be single idler pulley at the or that may be the compound idler pulleys. And fifth one is compound belt drive. And sixth one is or stepped or cone pulley drive. Okay. In this slide, we discuss uh, one by one of the types of belt drive. First one is open belt drive. In the left side figure, you can see the open belt drive. It is used with a shaft arrangement parallel and rotating in the same directions. That means both driver pulley and the follower pulleys are moving in a same directions, and the driver pulley drive the follower pulleys, and the driver pulley pulls the belt from the one side and uh, the deliver to the other side. Thus the this one is the tension side, or इसको we can call that lower side, your tight side. That means in the tight side uh, or the lower side, whereas the tension is more than the slack side. Second one is cross belt drive. Right hand figure is the cross belt drive, where we can see that both the pulleys are moving in opposite directions. And in that case also the driver pulley pulls from one side and deliver to the other side. Thus the tension in the uh, pulling side is more than the slack side. This one is the cross belt drive. And third one is the quarter turn belt drive. The quarter turn belt drive is also known as right angle belt drive. As shown in figure, it is used with shaft arranged at right angle and rotating one definite directions in order to prevent the belt from leaving the pulleys. The width of the face of the pulley should be greater than or equal to the width of the belt. Okay. Uh, this one is the stepped or cone pull drives. Basically, these are used for changing the speed of the driven shaft, while the main or the driven shaft runs at a constant speed. And this is basically accomplished by shifting the belt from one part of the step to another for requirement or the adjustment of the speed. Next one is belt drive with idler pulleys. Uh, in the right side of the slide, you can see the belt drive with single uh, idler pulleys, multi-idler pulleys, were used with shaft arrangement parallel when the open belt drive cannot be used to small angle of contact to the smaller pulley. Basically, the use of this drive to obtain high velocity ratio when the required amount of belt tension cannot be obtained by other belt drives. Next one is compound belt drive. in compound belt drives is used when power is transmitted from one shaft to another by a number of pulleys. Now, in this slide, we are going to derive the expression of length of an open belt drive. First, we draw uh, an open belt drive. As we have already discussed in previous slide about the open belt drive, where uh, as we know that in open belt drive, both the pulleys are drive in a same direction. So the in this figure, I just put two pulleys. Left hand side is the bigger pulley and right hand side is the smaller pulley. I just naming all the parts of the open belt drive. In this figure, let R1 and R2 let R1 and R2 are the radius of the larger pulley and the smaller pulley, and x is the distance between the two center of the two pulleys. This one is the bigger pulley and that one is the smaller pulley. It is the distance between both the pulley, that is x. And L is the total length of the belt. That means if you start the point G and it all over the pulleys and ends in and G, that is the L of the pulley, that is total length of the pulleys. Let let the belt leaves the larger pulley at E and G and the smaller pulley at F and H as shown in figure. Through as shown in figure through O2 and draw the line O2M which is parallel to FE. From the geometry of the figure, we can find that O2M, that is O2M, will be perpendicular to O1E. Let MO2O1 equal to alpha. I just assume that MO2O1 is equal to alpha. As we know that L is equal to total length of the belt, then L equal to arc of GJE plus EF plus arc of FKH plus HG. As arc of GJE, arc of GJE, you can put two part, that is GJ and JE. As both the part are same, so I just put arc of JE, 2 arc of JE plus 2 arc of EF and 2 arc of FK. So I just common 2 and put arc of JE plus EF and arc of FK in the bracket. From the geometry on the figure, we are putting that alpha sin alpha equal to O1M divided by O1O2. Since the value of alpha is very small, so that alpha, we just put the value of alpha, that is R1 minus R2 divided by X. So that arc of J equal to r1 whole into pi by 2 plus alpha, and arc of fk r2 equal to pi by 2 minus alpha. Now find out the value of EF. You can see in the figure that EF equal to MO2. So we just put the Pythagoras theorem, that is O1 O2 का whole square minus O1 M का whole square का root over. In place of O1 O2 we just put x square, as the O1 O2 is the distance between the two pulleys. uh, x1 x का square minus r1 minus r2 का whole square का root over. And after that I getting the value of EF, that is equal to x root over into 1 minus r1 minus r2 by x का whole square. Now putting all the values of arc of J, arc of Fk and value of Ef in the equation, that is L equal to 2 whole into putting the value of arc of J, that is R1 whole into pi by 2 plus alpha bracket close, plus the value of EF, that is x minus R1 minus R2 का whole square divided by 2x, plus value of Fk, that is R1 whole into pi by 2 minus uh, minus alpha bracket close. And after putting all the values, I derived that equations one by one. In that, here I just putting the value of alpha equal to r1 minus r2 by x, and after that in last I just got the value of the uh, length of the open belt drive equation, that is alpha whole into r1 plus r2 plus 2x plus r1 minus r2 ka whole square divided by x. It is the expression of the open belt drive in terms of radius. If we put if we want to get the formula in terms of diameter, then in place of r we just put the d by 2. Then we got the formula, that is pi by 2 whole into d1 plus d2 plus 2x plus d1 minus d square ka whole square divided by 4x. That is the expression of length of open belt drive in terms of uh, diameter.